Today we're going to continue our discussion about the classification of matter by talking about physical and chemical properties of matter, as well as physical and chemical changes. Matter has certain properties, and we know that matter can be classified by these properties. Yesterday we learned about pure substances and mixtures. So if we have some amount of matter, we can say, is it a pure substance? Is it a mixture? If it's a mixture, what type of mixture is it? But these properties themselves can also be classified as physical properties or as chemical properties. Let's get into that a little bit more. Physical properties describe a substance and can be observed and measured without changing the composition of the substance. That's the key part here, without changing the composition of the substance. There are a couple of examples of physical properties. These include color, size, shape, hardness, texture, flexibility, mass, volume, density, conductivity, malleability, and even more than that. Temperature, melting point and boiling point, magnetism, and viscosity. Yikes, what a load of physical properties. Let's look at these a little bit more. Okay, we know about color, right? Roy G. Biv. Size, large, small. Shape, do we have cubic pieces of matter? Do we have cylindrical pieces? Are they skinny and flaky? Then that brings us to hardness. So if you think of something that's very hard, like diamond, that has a completely different hardness than something like chalk. There's also texture. Is it rough or smooth? Flexibility. If we think back to the element sampling activity and we think about the copper wire, remember that copper wire was super flexible, like aluminum foil, for example. Plus, let's talk about mass, volume, and density. We know that those three things are related. Conductivity is a little bit of a tricky one. Conductivity has to do with heat and electricity. We also just recently learned the definition of malleability, right? That means that something can be pounded into sheets. Then there's temperature of the matter. Is it hot, cold, somewhere in between? Does it have any magnetic properties? What is its melting point or boiling point? Then viscosity, how easily it flows. This one only counts for liquids. This one only works for liquids. If we've got liquid matter, then we can talk about viscosity. If it is really thick like molasses, it's going to have a very high viscosity. If it's more like water, the viscosity will be lower. And using these physical properties, we can talk about separating a mixture. Now, we know that there are a couple different types of mixtures, right? We've got our homogeneous mixtures and our heterogeneous mixtures. And we need to be able to separate those sometimes. And so I'm going to list for you some different ways that we can separate mixtures. The first way is through filtration. Filtration separates mixtures based on the different sizes of components in the mixture. So if we had a mixture of birdseed and sand, well, we could probably use filtration of some kind to pull apart the bigger birdseed pieces from the very tiny sand pieces. So filtration is about the size of the components. We could also do distillation as a separation technique. Distillation is based on the boiling point of a substance. So maybe you've heard of this in regards to distilling salt water, right? So if we boil water high enough, we can evaporate all of the water away and we're left with salt. And if we properly collect the water, maybe now we have fresh water. So if you have ever heard about trying to survive on a desert island, you might need to find a way to distill salt water into fresh water. Crystallization is the sort of opposite of what I was just talking about. Same sort of thing, right? If we allow water to evaporate, we get that salt left behind, that crystalline solid. So whereas distillation, maybe you're trying to separate two liquids, crystallization is something really good if you're trying to separate a liquid from some sort of solid component. There's physical separation, just anything you can separate out by hand. So if you want to just like pick pieces of ice out of a glass of water, well, that's pretty simple. That's physical separation. Lastly, we have chromatography. That's a pretty big word. Basically, chromatography is allowing a liquid to rise up on a piece of paper. Maybe we've seen before drawing just a line on a piece of paper with marker or Sharpie and then putting it near water, and you can sort of see how the marker line separates into different colors. Moving on to chemical properties. Chemical properties describe the ability of a substance to produce a change in its composition and can only be observed or measured when the substance undergoes a chemical reaction to create something new. Let's highlight that, guys. Chemical properties can only be observed or measured when the substance undergoes a chemical reaction to create something new. Whereas physical properties, right, can be observed and measured without changing the identity of a substance, without creating something new, with no reaction taking place. Let's look at examples of chemical properties. The big two that you guys need to know are flammability, how easily something burns. So maybe a piece of paper is going to burn a little bit better than aluminum. The second example is reactivity, how easily something chemically combines with other substances to create something new. And you'll see this more in a lab situation. But reactivity is how easily something chemically combines with other substances to create something new. Not all chemical compounds are created equal. Some are formed very readily and some are not. When we talk about physical and chemical properties, often it's in the context of physical and chemical changes. So physical changes happen when some of the physical properties of a substance change, but ultimately the composition of that substance remains the same. So we've got our physical properties, color, hardness, texture, conductivity, and we're changing something about the substance, but we are not changing the identity of the substance, and that's what a physical change is. Some physical changes are reversible, and some are not. Some reversible physical changes are maybe folding a piece of paper or melting an ice cube. But on the converse, some physical changes are irreversible, like cutting a piece of paper. So it's not enough to say that a physical change is something that can be reversed, right? Because if we cut a piece of paper, well, we know that it's still paper, right? Our two halves of a paper are still made of paper. They're just in smaller components. Peeling an orange is the same thing. I mean, now we have an orange peel and a chunk of orange, but they're both still the orange. They're both still the same identity. Chemical changes, on the other hand, happen when new substances are formed, right? Physical changes, the identity of the substance doesn't change. In a chemical change, we do have new substances. So some great examples of chemical changes include cooking, right? Especially baking, right? When we think of turning eggs and oil and cake mix, if you're lazy like me, we turn that into a cake. It's something totally different than it was before. Digestion, let's think about it, is what we put in our body, and does it come out looking the same way? And then there's also burning. I know you guys have had bonfires before. Explosions, like fireworks, right? Rusting, leaving your bike out in the rain. Spoiling, when you just don't eat the bread or eat the leftovers and they start growing mold. And then in the context of more specifically chemistry, any chemical reaction is going to be evidence of a chemical change. There are some shortcuts to remembering what things are considered chemical changes. There are some clues. There are 4 clues that can help you tell if a chemical change has occurred. These clues, unfortunately, are not 100%. The only way to know for sure if a chemical change has occurred is if a new substance has formed. I will tell you these 4 clues. You do need to know these. The first clue is a change in color. A change in color. This is not like a physical property. Yes, color is a physical property. I'm talking about a change in color. If something is blue and it becomes red, that is a change in color. If we go back to the first lab of the year where we had that lovely reaction between our two solids and our liquid, and we had some yellow colors, we had some pink colors, that's what I'm talking about. That's a change in color. That lab was a great example of chemical change. The second clue is the production of a gas or gas evolving. If we again think back to that lab, we saw the plastic bags inflate with some sort of gas, right? We learned later that that gas was carbon dioxide, but that is a spontaneous production of gas. That's a spontaneous gas evolution. Evaporation is not a chemical change. Yes, I know that when something changes state from a liquid to a gas, it is becoming a gas, but that doesn't mean the gas is being produced. You see the difference? The third clue is the formation of a precipitate. And what a precipitate is a solid cloudiness that forms from a liquid mixture. So if you have two liquids and you combine them together in a container, you might get some sort of really thick, maybe a different color sort of solid that forms within the liquid. That's what a precipitate is. Now, our last clue is a temperature change. Again, I'm going to highlight change here. The physical property of temperature, whether something is hot, cold, room temperature, etc., that is a physical property. I'm talking about a change in temperature. Again, let's go back to that first lab. We had a cold bag, we had a cold side to the bag, we had a warm side to the bag, but originally at the beginning of the experiment, everything was room temperature. So those are the 4 clues to a chemical change. Remember, these clues aren't 100%. Something might change color, and it might not be a chemical change. So the key here is to look and see if there is a new substance present, then a chemical change has occurred. If there's not a new substance present, then a chemical change has not happened. If you want a brief overview of what I just talked about with the types of physical and chemical changes, here's a great chart you can copy down into your notes. Everything on the left side is going to be evidence of the chemical change. Everything on the right side is evidence of a physical change. That's all I have for you guys today. Thanks for listening to this lecture on physical and chemical properties and changes.